In this question, we're going to look at some probability stuff. If you're familiar with a thing called the hypergeometric distribution, this is the hypermetric distribution. So here's the question. We're going to sort of work this on the basis of basic probability and combinations and permutations and stuff like that. A team of 5 people is required to perform a particular task. So we need a team of 5 people. And we have 10 people to choose from. We have 7 women, okay, and 3 men to choose from, okay. So there's 10 people altogether, 7 women, 3 men, and the first question is, well, all of the questions are how many selections are there, so on, altogether, okay. So there's no sort of gender breakdown, there's no sort of constraints whatsoever. We have 10 people. How many ways are there altogether of choosing 5? So from 10 people, choose 5. Okay. So that is 10 factorial. This is the choose operator, binomial coefficients. Okay. So 10 minus 5, so 10 factorial, 5 factorial, and 10 minus 5 is 10. 10 minus 5 is 5 also, so 5 factorial again. So that is equal to 10 by 9 by 8 by 7 by 6 by 5 factorial, okay, over 5 by 4 by 3 by 2 by 1 by 5 factorial. If you're not familiar with binomial coefficients, I suggest you have a quick look at one of the videos instead. We can cancel out the 5 factorials there, above and below. Essentially what I've done there is wrote 10 factorial as 10 by 9 by 8 by 7, so we quickly identified 2 things to cancel out, the 2 5 factorials above and below. I'm going to do some more cancellations here. 8 can cancel out with 4 and 3, for example. 3, that can cancel out with the 6 to give, just leaving a 2 there. And 5 will cancel out with a 10 just to leave a 2 there. The 1 will just sort of leave alone. So that is 2 by 9 by 7 by 2, and that is equal to a little bit of calculator work. 63 by 4 is 252. Okay, there are 252 ways of choosing 5 people from 10. Okay, so that's the first part. The next part is if one of the men is an expert. Okay, so I just wrote it out there. If one of the men is an expert and must be chosen, so it's one of the men in particular must be chosen. So essentially what we have is we have 5 positions. Okay, so position 1, position 2, position 3, let's say. These are just sort of position sort of indicators. Okay, and let's say one of the men, let's call him ABC, are the men. A has to be chosen, okay, no matter what, but we have 4 spots left for the remaining people. For example, we don't pick any more men. Let's say we have all the rest. Let's say it's B, C, F, and G. Those are their identifiers. That's just one sort of possible outcome. But no matter which way we do it, we're only really picking 4 people. One of the men must be picked. Now, there's no gender breakdown other than that in this one yet so far. So essentially all we're doing is picking from the remaining 9 people, picking 4. Okay, so that's all it is. We have 1 person who must be chosen, so essentially we have 9 people left and we just have to choose 4 from them. So again, 9 factorial over 4 factorial times 5 factorial, and that is equal to 9 by 8 by 7 by 6 by 5 factorial all over 4 by 3 by 2 by 1 times 5 factorial. The 5 factorials cancel out. Okay, The 4 and the 2, they cancel out with the 8. The 3 cancels out with the 6 to leave a 2. So essentially what we have there is 9 by 7 by 2, that is 126. There are 126 ways of choosing a group of 4 people from 9, considering that's all we're really doing. That the only thing about the man must be picked is that we've only got 4 options to go. So anyway, the next question is, if 2 people do not get on. Okay, hang on a second, I'll write this down. So 2 people do not get on and can't be on the same team. Okay, so what we're going to do is have to think very carefully about this. This one is now much tougher. So essentially we have 5 people altogether, and let's just write it out there. Let's call our 2 people A and B. Okay, A can be on the team, but that means we can't pick B. Okay, so 2 people, let's call them A and B, just for the sake of clarity. So we could pick C, E, F and I, or we could have a different sort of setup. B is on the same team with D, E, F and I, or something like that. Those are 2 ways we could have it, but we can't have A and B. Okay, now but there's an also just read the question very carefully. Okay, consider this as a team: C, D, F, G, H. Okay, what's going on there? Neither A nor B are on the team. Okay, that's very important to think about that. So what we have here is 2 scenarios. One of them is on the team, okay, or neither of them are on the team. Okay, so we have so let's say we have a team with A, okay, a team with B, or a team with neither of them. Okay, so we have 3 scenarios. Okay, scenario 1, A is on the team. Scenario 2, B is on the team. Scenario 3, neither of them on the team. Okay, so in this situation we have 8 people left. B can't be on the team, and in this situation A can't be on the team. So in both of these cases, essentially we have 8 other people. Okay, so in the first case, what we're doing is choosing 8 from 8, choosing 4, and again in this situation from 8 choose 4, and in this situation from 8 choose 5. So the number of ways we can have this scenario here where these 2 people can't be on the team is 8 choose 4 plus 8 choose 4 plus 8 choose 5. Okay, now rather than work out the calculations, what I'm going to do is actually just provide the answers this time around. You can do it the same way I've done it in the last questions, but this is 8 choose 4, you will get 70 plus 70. 8 choose 5, you would actually get 56. So there are 196 ways you can get A or B on the team. 2 people do not get on together and can't be on the same team. Okay, so you have A on the team, you have B on the team, or you have neither of them on the team. The best way, the thing is just to consider what exactly is meant, okay, and what it means and what sort of is allowed, because a lot of people would sort of miss this last scenario. Okay, that neither of them have to be on the team. Okay, so that is that part there. So we'll move on to the next one now. Actually we won't. What I'm going to do here is I got 3 of these sort of scenarios left, so this is probably a good time to break the video down, and I'll go on to a part B because this is nearly just 10 minutes long.